Hello students, welcome to the second lecture of first order linear differential equation. Here we are going to look into the two examples and we'll see how we can solve a linear differential equation. So let's consider the first one. So it is dy dx plus 4x upon x square plus 1 into y is equal to 1 upon x square plus 1 whole cube. Now, if you look into the equation, then the equation is of the form dy dx plus p of x into y is equal to q of x, where p of x is 4x upon x squared plus 1 and qx is equal to 1 upon x squared plus 1 whole cube. So integrating factor will be equal to, because the first step is to find the integrating factor once we have found out our px and qx. So the formula is what? E power integral p of x dx. So in this case it will be e power integration 4x upon x squared plus 1 dx. Now if you integrate this, so this is nothing but your e power 2 times log of x squared plus 1, which is equal to x squared plus 1 whole square. Now here ln I am writing, that means this is nothing but log of x squared plus 1 to the base a. Okay, so next the solution will be given by then y of x into integrating factor, which is equal to x squared plus 1 whole square, which is equal to integrating factor, that is x squared plus 1 whole square into q of x. Now our q of x is what? 1 upon x squared plus 1 whole cube dx plus c. C is the constant of integration. Now if you simplify this, so we'll get what? Y of x into x squared plus 1 whole square is equal to integration 1 upon x squared plus 1 dx. So if you see here, this is x squared plus 1 whole square and here it is 1 upon x squared plus 1 whole cube. So after simplification, you will get only 1 upon x squared plus 1 and here plus constant of integration. So therefore, final answer will be y of x into x squared plus 1 whole square is equal to, now integration of 1 upon x squared plus 1 dx is nothing but tan inverse of x plus constant of integration, that is c. You can also write, now this you can consider as your required solution, and if you want you can also write your y of x as the explicit function, that is y of x you can express as a function of x only, that is y of x is equal to tan inverse of x upon x square plus 1 whole square plus c upon x square plus 1 whole square. So that way also you can write. So one good part about a linear differential equation is that you can actually express your solution y as a explicit function. So now let's consider the second one. So dy dx plus 2y tan x is equal to sin x. So we have dy dx plus 2y tan x equal to sin x. Now this 2y tan x we can also write as 2 tan x into y. So in that case we will be able to write the equation as dy dx plus p of x into y is equal to q of x, where p of x is 2 tan x and q of x is sin x. So same way we can start. So the integrating factor is e raised to integration p of x dx, that is e raised to 2 times integration of tan x is log sec x, and which is finally comes out to be a sec square x. And thus the solution will be given by y of x into integrating factor, that is sec square x is equal to integration sec square x into sin x dx. This is nothing but your integrating factor into q of x plus constant of integration c. So which implies y of x into sec square x is equal to integral tan x into sec x dx. Now if you simplify this, sec square x into sin x, so you can write this as tan x into sec x plus c. So this implies yx into sec square x is equal to, now integration of tan x into sec x is nothing but your sec x plus c. So which is the required solution. Now in case if you have any doubts, so you can write your doubts in the comment section. So I'll answer your queries.